So now we move on to the numericals which are there based on the pulley system. So that is exercise 3b, the numericals part. That is, there are 11 such questions. So let us go through them one by one. Now before we start that thing, we should also be going to the different formula which will be required for the pulley. So considering that particular part, we see the first thing as the mechanical. So first one is mechanical advantage is equals to load upon effort. The second thing will be velocity ratio. So this is just for a normal pulley. So velocity ratio will be equal to dE upon dL, that is distance moved by the effort upon distance moved by the load. Then we have the efficiency is equals to MA upon VR, that is for a normal pulley. So these things are for pulley, normal pulley, whereas the fourth one will be VR is equals to 2 raised to n. This is for combination pulley. Okay, this is for combination pulley. Of course, MA is also raised to 2 raised to n, which is also for combination pulley. And the next one is the sixth one, which is going to be VR is equals to n, that is number of pulley in block and tackle, and MA is also is equals to n, which is again the same thing. This is for block and tackle. Okay, so block and tackle system is going to be this as the one part. Sorry, block and tackle system is going to be this way. And last one, if at all, they normally don't ask, but if at all they ask, then the when W is so when we consider W, then efficiency is equals to 1 minus NW upon E. So that will be the W upon NE, that will be the efficiency for W as weight of lower block. Okay, W is weight of lower block. Then you got efficiency is equal to 1 minus W upon NE, and also I will write down MA also. MA will be equal to N minus W upon E. Okay, this is for the lower block. So we see that normally it will be these kind of the formulas, that is MA is equal to load upon effort, VR is equal to effort upon load, efficiency MA upon VR, VR is 2 raised to n and MA is 2 raised to n for combination pulley, and VR is equal to n and MA is equal to n for a block and tackle system. But if we take the W as the weight of the lower block of the pulley, then efficiency is 1 minus W upon NE and MA is equal to n minus 1 W upon E. So these were the different this was different formula which to be used. So let's start with the exercise now. So exercise 1, first question. A woman draws water from the well using a fixed pulley. The mass of the bucket and the water together is 6 kg. So you can see the load is equals to mass of bucket plus water is equals to 6 kg. The force applied by the woman is 70 Newton. So the effort applied is 70 Newton. We need to find out the mechanical advantage with G is equals to 10. So G is equals to 10 meter per second square. Therefore load is equals to 6. Load is equals to M into G. So that will be equal to 760 into 10 is equals to 60 Newton. So if for MA is equals to load upon effort, so that will be 60 upon 70. So that will be 6 upon 7, that is going to be 0.857. So MA is 0.857 for the first answer. Clear? We now move on to question number 2. In the second question, you can see a fixed pulley is driven by a 100 kg mass falling at a rate of 8 meters in 4 seconds. it lifts a load of 75 kg. Calculate the power input to the pulley, taking the force of gravity on 1 kg is 10 Newton, the efficiency of the pulley, and the height to which the load is raised in 4 seconds. So let's see one by one. This is an important question. This sounds like slightly difficult also, because there are too much of data being asked. Plus, they are saying that it lifts the load at a particular rate, the rate at which it is falling. So, okay, a fixed wheel driven by a 100 kg mass falling at a rate of, so the effort, we can see this, that the effort over here is 100 kg. Okay, effort is 100 kg, and it is moving at a rate of 8 meters in 4 seconds. So it is driven by a mass of 100 kg. So first of all, effort is equals to 100 kg. The velocity with which it is falling is given as 8 meters in 4 seconds. That is 8 upon 4 is equals to 2 meter per second. Okay. They ask us if it loads, if it lifts a load of 75 kgf, so load is equals to 75 kgf, right? And they ask us the power input. Power is equals to work upon time. So first of all is power is equals to work upon time. Work is nothing but the power input. They are asked us the power input. Now input is of course the effort. So that will be work upon, what is work? It will be displacement. So that will be work per second, and that is going to be effort into G, or we can say F into V upon T, because work is also force into velocity. So F into V. So that will be giving us the formula for this is F is nothing but effort into G. So G is given as 10. G is equals to 10 kg per Newton. Okay. So that will be equal to 100 into 10 into velocity is 2 upon time is going to be 1 second, because we are taken over here like this. About 1 second. You could have taken over here 8 upon 4. They will give the same answer. So accordingly it is 2000 watt. So 2000 watt is the power input. So the power input is 2000 watt. Right? Work is force F into V, because, or we can say F into S also, but it is per second, so it will be V. So it's not different. Yeah, this is the input power. The next is the efficiency of the pulley. So we need to find out the MA and the VR. Okay, so we have over here the MA is, see VR is 1 because it's a fixed pulley, so VR is equals to 1, VR is equals to 1 fixed pulley, and MA is going to load upon effort is equals to 100 upon 75, so that will be equal to 4 upon 3, right? Sorry, effort, sorry. MA is equals to load upon effort. Load upon effort. So load is 75 upon 100. So that is 0.75. Therefore efficiency is equals to MA upon VR is equals to 0.75 upon 1 is equals to 0.75 is equals to 75%. So that's the efficiency, 75% or 0.75, whatever you want to take it as. And finally, the height to which the load is raised in 4 seconds. So height to it, we can know that VR is 1. So VR is equals to dE upon dL. So because it is dE upon dL and we know that velocity is 1, dE we know is nothing but 2 meters per second. So it is 2 meters. In fact, they asked in 4 seconds. So it is 8 meters. This is the effort. So load will be dl will be equal to. So dl is equal to 8 meters. So that will be the distance traveled by the load, where the height to which it is going to be raised will be 8 meters. Okay. So this is an important sum. You can mark this thing an important sum because it has got a good amount of understanding to be done. So yeah, firstly we have to understand the power input. What is power input? Work upon time. What is the work done by the effort? Power input is work done by the effort. So what is the work done by the effort? Force into displacement. What is the displacement? Displacement is per second. That's why we are taking it as meter per second. Velocity is taken in meter per second by 8 upon 4. Or you can directly put over here 8 upon 4 and you can get the same answer. So not a big issue. You can always get that particular 2000 watt. And then you have MA is L upon E and VR is already 1 because of the fixed pulley. So it will be 0.75, efficiency 75%. And the VR we already know it's 1, so it will be DL will be 8 meters. So this was your second question. Now we move on to sum number 3. Moving to sum number 3, it is a single fixed pulley and a movable pulley both are separately used to lift a load of 50 kgf to the same height. Compare the effort applied. So it's a simple thing over here that you have to compare the effort applied. So first of all you can say single fixed. So in case of single fixed, MA is equals to 1, VR is equals to 1. So we are not required, we will just require the MA. So MA is equals to 1. Therefore, MA is equals to load upon effort. So 1 is equals to load is 50 and effort is equals to E. So we see that E is going to be 50 kgf. In case of a movable pulley, we see MA is equals to 2. Therefore, MA is equals to load upon effort is equals to 2 is equals to 50 upon E. So E is going to be 50 upon 2 is equals to 25 kgf. Therefore, E upon E will be equal to 50 upon 25 is equals to, we'll take E1, E2, sorry, E1 and E2. So that will be 2:1. So 2:1 will be the ratio in which the effort will be applied in both the cases. Twice the effort in the fixed pulley and half the effort in the movable pulley. We move on to sum number 4. In a block and tackle system consisting of 3 pulleys, a load of 75 kgf is raised with an effort of 25 kgf. Okay, so we do not draw the figure because they don't ask us, so not required as such. They have given us the load and the effort. So fourth one is load is equals to 75 kgf. You get the effort is equals to 25 kgf. Okay. You need to find out the mechanical advantage. So mechanical advantage is equals to load upon effort is equals to 75 upon 25 is equals to 3. So MA is equals to 3 and velocity ratio is equals to N, that is number of pulley, and that is given as 3. So velocity ratio is also 3. You need to find out the efficiency. So efficiency is equals to, this is the second part, this is the first part. The third part over here is the efficiency. Efficiency is MA upon VR. So that is going to be 3 upon 3 is equals to 1 or 100%. So that's the efficiency, 100% for this particular block and tackle system having 3 pulleys. So that was your sum number 4. Now we move on to sum number 5. A block and tackle system has 5 pulleys. If an effort of 1000 Newton is needed in the downward direction to raise a load of 4500 Newton, calculate the mechanical advantage, velocity ratio and efficiency. So again, it is the same thing. Fifth one, N is equals to 5 pulley. Therefore, VR is equals to 5. Load is given as 4,500 Newton and effort is given as 1000 Newton. So MA is going to load upon effort is equals to 4500 upon 1000 is equals to 4.5. So that is the MA. MA is 4.5 but VR is equals to 5. So first thing is MA, second thing is VR. VR is equal to 5 as per the number of pulley, that is number of pulley. And finally efficiency. Efficiency is equals to MA upon VR, that is going to be 4.5 upon 5 is 0.9 or 90%. So that is efficiency as 90% or 0.9. Okay, that was sum number 5. Is it clear? Now we see a sum which is related to drawing of things. So let's draw it first. I think I'll use both the sides so that I can draw on one and do the calculation on the next one. So what we have is a block and tackle system as per the figure, which is 3 at the top, sum number 6. This is the rigid support, and to this rigid support are 3 pulleys connected. So this is the first pulley, the second pulley, and then we have the third pulley over here connected to the hook. The hook is connected to another 2 pulleys, one here and another here. Now this is connected to the load. This is what is given to us. Now they are asked us to, first of all, mark in the diagram the direction of the load. So first of all, draw a tackle to lift the load to apply the force in the downward direction. So we are applying the force in the downward direction. So accordingly, the tackle will be from top. It goes from here, goes down to the last one of the movable, then it comes up to the one in the non-movable, then again movable, then again in the fixed one, and then it comes and connects to the movable part. So you see that you will be having 1, 2, 3, 4, 5 T's over here. So here it is T and the effort is downwards. Okay, the load is going to be downwards connected here. So first of all, mark the diagram in the direction of the load and the effort. So of course the direction of the load is downwards. This is the downward force, and this is the effort is also downwards. So both are downwards, and the T accordingly are upwards in all the cases, which are the reaction force. If the load is raised by 1 meter, through what distance will the effort move? So the first question is, we have got over here that VR. So the second one over here is, it is in the form of B. So B part VR is equals to N. So that is equals to 5. Now distance moved by the effort, they are given that if the load is raised by 1 meter, so difference moved by the load is 1 meter. So DE is what we need to find out. So we know that VR is equals to DE upon DL, and hence 5 is equals to DE upon 1. Therefore DE will be equal to 5 meters. So the distance moved by the effort will be 5 meters. Then we see the C part. The C part is, state the number of strands of tackle supporting the load. So number of strands is equals to 5. That is what we have seen. 1, 2, 3, 4, 5. The 5 arrows here. 1, 2, 3, 4 and 5. The 5 tackles. Now what is the mechanical advantage of the system? So mechanical advantage over here, are we given the load and the effort? It is given that it is nothing here. Those ka matlab hai, it is going to be an ideal machine, because we are considering it to be an ideal machine. Therefore MA is equals to we are assuming an ideal machine. Therefore, MA is equals to 5. Okay. So this is what was the sum number 6 of the exercise. We now move on to sum number 7. Okay, this is now sum number 7. So sum number 7. A pulley system has a velocity ratio 3 and an efficiency of 80%. So we have got that the velocity ratio is equals to 3 and the efficiency is equals to 80%. Draw a label diagram of this pulley system. The velocity ratio is 3, so it will be a block and tackle system. Label diagram of this pulley system, and like the mechanical advantage and the effort required to raise a load of 300. So they are given over here the mechanical advantage. So first time efficiency is equals to MA upon VR. So that will be 80 upon 100 is equals to MA upon VR is 3. So that will be 80 into 3 upon 100 is equals to MA. So that will be equal to, given as 0 to 24 upon 10 is equals to MA, so is equals to 2.4. So MA is 2.4. The next what we want is the effort required. So MA is equals to load upon effort. So 2.4 is equals to load is given to you as 300. So 300 upon effort. So effort is equals to 300 upon 2.4. Okay. So 3s are, so it will be 0. 8s are, and this will be 100s are, or 10s are, basically 10 upon 8. So that will be equal to 100 upon 9. 1 second. So it will be 3,000 upon 24. Okay. So 6 4s are 6 500. So now it is 125 Newton. So effort required will be 125 Newton, that is the B part. This was the A part. We are asked to draw the figure also. So the figure will be very simple. There is going to be this particular rigid support, and to this rigid support will be connected two pulleys, which will be fixed pulleys over here 1 and 2, and then there will be a hook and another hook over here. Connected to this will be another one single pulley like this, which is connected to the load. Now each and every time you need to show all this, okay? And then you are going to show the tackle. The tackle goes from here, it starts from here, goes straight into this particular point, and then it goes right over here and then ends over here. So this is the T, T and T. This is the effort downwards and T upwards. So this is how the figure will be for this particular question number 7. Okay, this was question number 7 about the block and tackle system. Okay, we move forward to sum number 8 now. Sum number 8. This is a 4-pulley system, 4-pulley block and tackle system. So again, it is sum number 8. It is going to be like this: a fixed block having 2 pulleys on the fixed part. So 1 and 2, the fixed part, and then the hook. And connected hook over here will be the next one, which is going to be like this, which is 1 pulley and second pulley. This is what is already given to us, and with the load connected to the lower part like this. So this is the thing what is given. Now we need to do, first thing is, the upper 2 pulleys are fixed and the lower part is movable. Draw a string around the pulley. Also show the point of application and direction on which the effort is to be applied. So you are going to make the string. So the string will be starting from here. It goes here from top to the last, then to the next over here, then to the second over here, and then connecting to the thing like this. So this is T, T, T and T. So the 4 T's over here. The load, and over here will be T upwards and effort downwards. So we have given the point of E and over here, and what is the velocity of the system? So first, velocity ratio of the system, velocity ratio is equals to N is equals to 4. That is first part. How are load and effort of the pulley system related? So we can say load and effort related. So we know that MA is equals to load upon effort. So 4 is equals to load upon effort. Therefore effort is equals to load upon 4, or load is equals to 4 into effort. So this is how the effort and load are connected to each other. What assumption do you make to arrive to the above point? That is frictionless. So no loss in the system, and we can say, and it's an ideal machine. Only if it's an ideal machine, then you can get this thing as the correct thing. So that was the thing. So we have already given the assumptions. No friction between the bearings, weight of the lower block is negligible, and the effort is applied in the downward direction. Yeah, downward direction effort is also required. So effort downwards. Okay. So these are the things which are connected to question number 8. I think the next 3 sum we can do it in the next video. So yeah, we can take it in the next video.